My name is Jeffrey Blay, a second-year YSE from Dr. Sito's lab, and then a member of BIOMES committee. BIOMES basically provides a platform for inspiring and informing interdisciplinary research, policy, and then environmental conversations within the YSE community. And as part of that, this semester's seminar series focuses on the works of some faculty within the Yale community in general. So for today, our guest speaker, which I'm very honored to introduce is an emeritus professor at the Yale School, at the School of Design at the University of Pennsylvania, and an adjunct professor here at Yale School of Environment. He has been teaching geographic information systems since 1990 and is highly regarded as one of the early pioneers in this field. So, fellow YSEers, it is my pleasure to introduce to you Dana Tomlin.
Thank you, Jeffrey. You're going to enjoy this presentation. Not a lot, not as much as I will, but I dare say that you'll stay to the end, or at least many of you will stay to the end. And if you do, you're not really going to learn anything that you don't already know. But you will find yourself going to sleep tonight thinking about this lecture. At least that's my objective. In order to achieve that objective, I need a volunteer. Let's just imagine that you did volunteer. Our volunteer is here. And what I'd like you to imagine now is that you're participating in you guessed it, a duel. You okay? Right here? And I will imagine that I'm right here. I first came to Yale, we'll get back to you, in the mid-late 70s as a doctoral student. I did so because I, like many at that time, had become not smitten at all, but smitten with the prospect of computing. This was a time, however, when in order to gain access to a computer, one had to be a student or go to work with a big organization. This was prior to the days of desktop PCs. And although I don't think I've admitted it since, that was the reason I went into my doctoral program here in New Haven. And when I arrived, I found that I could get an account down at the computer science department on a mini computer, a PDP-20 mini computer that was inaccessible otherwise. But in order to do so, I had to go and meet with the director of grad studies down there. And I can remember like it was yesterday, leaving my apartment over here at the corner of Mansfield and Sachem, walking down and meeting with this fellow. He misunderstood my intent. He thought I was asking to take his class. So with all the confidence of a new doctoral student, I said, yeah, sure, that's why I'm here, to take your class and to thereby gain access to this computer. It was a class, I'd never taken a computer course before. This was a class in computational complexity. And I'm glad I did. This fellow ended up being on my doctoral committee. We had a great relationship for years after. But at that point, what I remember most is the first day of class, when at the end of the first session, he posed this problem. Imagine a duel. Now, this was in the early 70s when one would conjure up stories that might not be as politically correct today. This was a duel with lethal weapons, one of which is in your hand, one of which is in my hand. And the deal is this: one of us gets to go first. If fortunate, the other gets to go second. Whoever goes first has a weapon that is accurate 1/3 of the time. Whoever goes second has a weapon that is accurate half of the time. Who do you want to bet on? Not a rhetorical question. You're about to raise your hand. Down. This is what happened at the end of class. The problem was posed. What was different then from now is that there were hands that shot up. Not many, but a few hands that shot up, and the professor said, "Can I help you? What is it? This is the assignment for next week." But those few individuals said, "What do you mean, an assignment?" The answer is obviously that you are, absolutely right. It doesn't matter. The odds are, that's exactly what you're going to say, right? The odds are equal. And aside from the distress that might come from having to suffer the first shot, it didn't matter. So why just a few hands go up? Well, it's because those individuals were not inclined to cast this problem in terms of any sort of mathematical formalisms, but instead just to see in their mind's eye that there's this hunk of probability, to use the proper term, this hunk of probability that occupies 1/3 of the mass of all probability. And once that first shot is taken, that goes away, and there's a remaining 2/3, of which half will go to the other person. It's another third. Of the remaining third, same thing. Take away a third, take away a half, and so on. My point is this, that by visualizing the problem, it became trivial, maybe even enjoyable, at least for some people. And there are indeed some for whom using the mind's eye is just as natural as can be. For example, by the way, you can imagine yourself sitting down now, but I do need another volunteer to count backwards. In fact, why don't all of you quietly count backwards from 100 by 6. 100, 94, 88. This is February. Let's go through the year backwards. What I'm interested in is not your ability to do this, but what's going on up here? What do you see? Do you see a conventional calendar? Are you repeatedly, I hope not, reciting January, February, March, April, and trying to reverse them? Give me 3 months of the year whose sum total of days is equal to 91. In order to do that, you're going to have to know which months have 30 days. Not just by name, but you're going to have to position them, hence using the mind's eye. And like I say, there are some people for whom this is the most natural thing in the world. These tend to be people who prefer analog rather than digital watch faces. They are people who tend to speak by walking around and waving their arms. They're people who tend to see things in terms that are, let me say, pseudo-geometric in their mind's eye. There are some people who are, perverse enough to delight in this sort of thing. People for whom a standard exercise in a mechanical drafting class like this is just basket weaving. They love to do it. People for whom a question like the following is likewise delightful. The only daughter of my only father's only brother has only one aunt. So do I, and we share her. So why is it that my mother never answers my phone calls? Well, clearly, she's no longer with us. And you saw that immediately, didn't you, when you saw the relationship between mother and father? Of course you didn't. That's a little bit beyond what most people are likely to be holding in their mind's eye. But there is a difference among people in terms of their inclination, their ability to make use of this important type of capability. For me, this came perhaps clearest back in the mid-'80s when a colleague, actually a professor at the University of Connecticut, with whom my wife and I were going to spend the evening, and we had to go to a particular location, responded to my offer to describe how to get there by saying, "Dana, please stop. You don't understand. It's painful for me to hear you talk like that." And I was just giving him directions. I think I may have been so discourteous as to actually point in a direction. He said, "I've had brain surgery." No joke. "I've had brain surgery. And ever since," this guy worked, by the way, in forest statistics. Ever since his surgery, not only was he unable to do that kind of mathematical work, but it was actually painful for him. I learned later that it was just a few years earlier that a fellow named Roger Sperry had won the Nobel Prize for this sort of thing. That is, doing experiments that demonstrated that the left and right hand hemispheres of the brain operated largely separate from one another and could indeed be separated in interesting ways. Since then, we have words, aphantasia and hyperphantasia, that are used in reference to individuals who do or don't have this inclination, this ability to think in what I call these pseudo-geometric terms. I'm convinced that even if you're not inclined to think this way, it's not a bad idea to try to do so, to try to adopt some tips, some tools, some techniques to think of things in spatial terms. And it's in that regard that I cast this talk in terms of the overall theme of the BIOMES project, that is, to share with colleagues the way we see things, different researchers see things, the way we pursue academic problems. What I want to do today is to describe to you the kinds of mind's eye deliberations go on, at least in my mind, doing the work that I do, that I've done in the area of geospatial algorithm development. As I do so, I'm going to have to resist the temptation to talk about the algorithms per se, which I find extraordinarily interesting, and instead talk about the mind's eye processes by which they were created. I'm going to do this by offering some words of advice. And in fact, there'll be a dozen of these words of advice. You've probably guessed them, some of them already. They are lie, cheat, steal, scribble, juggle, muse, snooze, warp, wander, wonder. I didn't have room enough in the bottom to fit the last two, but get and high. And so what I'd like to do is to use these words of advice to structure my remarks, describing what's worked for me, in hopes that perhaps some of these will resonate for you. And I'd like you to do me a favor. I said at the beginning of my remarks that you really weren't going to learn anything this afternoon. Likewise, you're not going to have any questions at the end of this presentation, but I would like you to consider these terms, and I'm going to keep them keep them posted. I'd like you to, at least to yourself, keep a note as to which of them resonates most with you. Which of them is one for which you say, yeah, I do that same thing. It really works for me. I'm not necessarily going to go through these in the order that you see here. In fact, I'm going to start with cheat. Now, I don't mean that you should cheat in the conventional sense of the term. What I'm really talking about here is cheating in the way you cast problems for yourself, the way you use crutches. I'm talking about mnemonics. I dare say that within the last 15 minutes or so, some of you have uttered the phrase to yourself, 30 days has September, April, June, and November. That's what I mean. There are spatial mnemonics. For me, one that's particularly powerful relates to this game that was also a TV show when I was a kid. Concentration was a game that required you to remember what was beneath those little blocks that would turn up and down. And there was a home version of this game that came out. My parents got me a copy. I loved it. I loved it because I was good at it. And I was good at it because, from my perspective, that game board was a floor plan of the first floor of my house. I love the number of people who are, What could be easier than to remember what was over there in the corner of the kitchen, what sat in the middle of the dining room, what was over in the living room back corner, and so on. That simple spatial mnemonic, that spatial device, enabled me to prevail in that then important world. Those of you who may have been inclined to think in terms of a non-spatial mnemonic, 30 days has September. What about the question that I posed a few moments ago about the 3 months that in some have 91 days? In order to achieve that, you've got to have 2 of those 30 days and a 30-day months and a 31 month. Do you know that the layout of the months around the year are symmetric, such that around the split between July and August, we have 1 month and then 2, somebody's right. In other words, if you see it, you'll never forget it. What are you going to do in a few weeks when or let me put it this way, when in a few weeks we shift from daylight to daylight savings time, and it's the end of the day, is it going to get darker or lighter, quick? You don't know right offhand, do you? How many of you are falling back right now or springing ahead? But if you see it in your mind, it's as clear as can be that you're grabbing light from the future or the past. This is what I mean when I say cheat. Simply adopt these crutches. Now, I work in a world that is not only spatial, but geospatial. dealing with, more often than not, the face of the Earth that looks something like this, and representing that world, not in terms of points, lines, or polygons, but in terms of pixels. That is to say, the work that I do in geographic information systems, although it involves both discrete objects represented as points, lines, and polygons, also involves cartographic depictions as pixels, not unlike those in your megapixel camera, such that I would, if I were an animator, I'd be dealing with the Homer that you see to the right rather than the Homer that you see to the left. This gives rise to the second of my words of advice, and that is to lie. I don't mean lie to others. I mean lie to yourself. And I don't mean lie to yourself all the time, but lie to yourself for a while when you are initially taking on one of these geospatial problems, the design of one of these geospatial algorithms. What you're looking at right now is a cartographic rendition of proximity to building. You notice how the colors sort of rainbow out in these halos that get redder than yellower than bluer and purpler as you get farther away. Now think about the computation required to do this. Certainly it's going to involve this equation that we associate with the term and the person Pythagoras. That is to say, the distance between any 2 points is equal to the square root of the sum of the squares of the vertical and horizontal displacements. In a computer, it is considerably more expensive, more costly, more time-consuming to make use of an operation that multiplies or divides or takes the square root, as opposed to simply an add or subtract. And so if there's some way we could solve this problem better than going to every pixel and calculating Pythagoras, go to the next pixel, calculate the square root of the sum of the squares of the vertical and horizontal, doing the next, the next, the next. If there's some way we could make that more efficient by using more adds and subtracts, that would be great. And when I say lie, what I mean is this. Let's pretend that the problem is not as complicated as this. Let's pretend that the problem involves only one pixel and we're only interested in distance to its left or its right. That is, the problem is simply this. We start with that pixel that you see represented by the circle, and we'd like to generate to the right of it 1, 2, 3, 4, and so on. Now, as I said, we know that we're going to want to calculate the square of distance, and we prefer not to have to suffer the expense of computing squares as opposed to simply adding, but we want to end up with a sequence like that. Do any of you immediately notice something about this sequence? If not, in a moment, some of you at least are going to go, oh, of course, why didn't I saw it, why didn't I raise my hand and say it? I'm not going to give you the opportunity to do that. I want you to note that the difference between these is 1, then 3, then 5. So I can remember when this simple observation came to me. It was over at the corner of Sachem and Mansfield Street as a doctoral student here at Yale, and it was a big deal. Because if I could do that, I could then sweep the other way and do the same. And now get this, I could sweep down and thereby get the sum of the squares and the squares. I could then sweep up and get this. And what I end up with is the squares of distance. This is a big deal. A big deal because this measurement of distance is so fundamental at scales ranging from global and continental down to microscopic. I'm going to resist the temptation to talk to you about those applications and instead try to bring this closer to home in a way that would have been very close to home a few years ago. But I dare say even some of you now will recognize the classroom up at Great Mountain. Thank you for those of you who are acknowledging that. Because I spent a fair amount of time over the last few days developing a database for this area that places it up in northwestern Connecticut with chairs and stools and desks and doors and windows and so on, simply so that I could do this. So I'm going to use this, for some of you familiar, but certainly clear cartographic database to demonstrate some additional spatial algorithms in hopes of geospatial algorithms in hopes of talking to you about how they were created. Here what we're doing is measuring distance to one of the doors, distance as the crow flies. More interesting, arguably, than that is distance as the crow walks. Distance measured not in terms of feet or meters or miles, but distance measured in minutes or gallons of fuel or ergs of energy, units that vary from one place to another. What's your proximity to me right now? Well, you could measure that as the crow flies, or you could measure it in terms of how many seconds it'll take you to get to me, how many bruises, how many units of embarrassment if you try to get to me really quickly. And in this case, you can see that these zones of distance spread out from the door, and they wrap around the desks, and they wrap around the stools. The word of wisdom that I associate with this is scribble. And when I say this, I'm not referring to what you see just to the left of the word scribble, which, by the way, is a scrap that I found up in my attic a few days ago. I'm delighted to have done so for a couple of reasons. One, it relates to the 14916 problem that I described just a moment ago. But more importantly, at the bottom of this, if you looked quite closely, you'd see that there's a note that says, allow uncontrolled burn, allow relatively uncontrolled burn. What I meant by that is that the algorithm that does this is one that starts from that door and then generates these propagating waves that refract and diffract as they move from pixel to pixel across space. And for me, the term scribble can be applied here because of the idea of generating a trail, deliberately littering when you're working with this stuff. Maybe it's a scribble on paper like this. Maybe it's mumbling to yourself as you go, but leave something behind. Now, I can remember when I wrote the algorithm for this, it was actually before I came to Yale. My wife and I were living up at the Harvard Forest, and I would travel into Cambridge into one of these computers that's the size of a building. And this was in the days of punch cards and fan fold paper. I am so pleased with the blank looks on your face because I anticipated that and brought with me, therefore, some fan fold paper. These were the printouts that one would get from the computer center. And what my wife and I would have to do with them is exactly what's implied here, and that is we'd lay them out on the floor of our apartment to see whether or not they worked in terms of this sort of thing. Two things about this. One is that suffering the hour-and-a-half drive from Cambridge out to Petersham was, as I look back on it now, really therapeutic. It was really helpful. And when we got home, laid these things out and saw the mistakes, the cancerous explosions of pixels, they were so evocative that it really helped to hone and to improve on that algorithm. I'm going to move on hastily for fear of not getting to all 12 words. Notice the difference between this. Look closely at those white lines over the blue room. That and that. What do you notice? These are nice and rounded and smooth, but the earlier ones were octagonal. Any idea why? It's because in that process of exploding from the door and propagating across space, that wavefront had to move from pixel to pixel. Each pixel has only 8 neighbors, which means as I'm propagating, and I want to make sure the camera doesn't see me when I do this, I have to move from pixel to pixel to pixel to pixel to pixel to pixel to pixel. The question is how to avoid that. And I can tell you that this was a problem for 25 years. I'm serious when I tell you that I thought about this for decades and finally was able to resolve it years later after taking a sabbatical and realizing that the key was to steal. In this case, I stole from Ariadne. Familiar name to anybody? Ariadne was the woman who told Theseus how to get out of the labyrinth after having slain the Minotaur. How did he do it? What suggestion did she give? Come on. Lay a thread, a string behind him once he worked his way in, and then use that to get back out again. It almost seems like cheating. When I think of this, I can't help but think of the Indiana Jones scene where he's confronting the ninja swordsman. Let me just leave it at that. The point is that by, let's not say steal, let's say borrowing, the insight came in order to solve this problem. Next word of advice. Be willing to muse about these problems. If you look up the term muse in the dictionary, it'll tell you that it simply means to think deeply about. To my ears, muse means more than that. It means a willingness to adopt metaphors and then go with them. For example, in this case, I'm taking this proximity to door, travel time proximity to door, and taking the 1 second, 2 second, 3 second contrast and treating them as though they are elevations in a pseudo topography. And so what you see here is a surface of travel time. Why is this useful? Because imagine you're standing on that surface. Here you are at 17 seconds from the door. You have a neighbor who's at 17 seconds, another neighbor at 23, another neighbor at 13. To whom are you going to step if you want to get to that door as quickly as possible? You're not going to step to a neighbor who's also at 17 or a neighbor who's at 23. You're going to step to the neighbor who is at 13. You are going to take a steepest, stepwise descending path and do it again and again. You are going to drain down over that surface and thereby follow the optimum path. Suppose you're looking for second best paths, third best paths. This gives rise, at least in my mind, to the next word of advice, and that is be willing to look at these problems from a different perspective, that is to warp the problem. Students in my classes often hear me urge them to think like a worm, not like a bird. Adopt a worm's eye view, not a bird's eye view. And If you do, in this case, it's as clear as can be how you would identify the first, second, third, fourth, fifth best path from, let's say, that corner of the room to that corner of the room to wherever you are. You know how to compute your distance from that corner of the room. You'd use that distance as the crow walks procedure that I described a moment ago. What else do you need to know? Well, you need to know your distance from where you are to that corner. Why not just reverse it and just make it that? So you use the same technique from this corner, you add them up and you get this. Simply a matter of looking at the problem from a slightly different perspective. Suppose we want distance from all of these stools. Every stool is taking its own optimum path, and the resulting set of timber harvesting trails, students walking from stools to the door up in Great Mountain Forest, is not very efficient. So how could I make this set of timber harvesting students up at Great Mountain more efficient? The technique required to do so is one that I developed for my wife as an anniversary gift. Yes, we have that kind of marriage. It's lasted almost 50 years now, so don't knock it. The answer is this: you take the existing traffic and regard the fact that someone's already traveled there as being something that will lower the friction, as being more desirable. And having done that once, you'll get a pattern that looks like this. And if I were to do it again and again and again, I would get a more efficient dendritic pattern for the same reason that channelization out on the face of the earth when it rains again and again and again results in deeper and deeper trunk lines. I won't belabor that except to say that this is an instance where looking at the problem as musing is of help. Next word is wander. And what I mean by this is to be willing to adopt heuristics. A heuristic is different from an algorithm in that an algorithm is a recipe that guarantees a set of precise steps toward a defined solution. Heuristics are the way we really make decisions in life. They're a series of best guesses, each intended to make progress and to learn a bit more about the problem. So what you're looking at right now are a set of potential cell phone users over in New London. And the question is, how could we lay out a constellation of cell phone towers to satisfy them? My suspicion is that your first inclination will be to locate that first tower and then remove its clients. Then locate the second tower, remove its clients. That works pretty well, but not as well as this. Take those towers and put them anywhere you'd like. Then ask every customer to ally with the nearest tower. Then go back to all of those customers who have allied themselves with an existing randomly located tower and ask them to move that tower to their center of gravity. Do it again and again and again, and you will have followed what's called a k-means algorithm that ultimately places these towers in positions that are not guaranteed to be the best, but are pretty good. This willingness to pursue and accept solutions that are pretty good is what I mean when I say be willing to wander. Snooze. If you read the Steinbeck quote, I probably don't have to say any more about this because I dare say that most of you recognize already that if you just let the elves do their thing at night after you've fallen asleep and learn how to interact with them before and after you sleep, it's extraordinarily productive. I can tell you that this is true not only in terms of soft problems, but in terms of very specific problems. The key is to learn how to interact with those elves the way you interact with your cat. That is, not try too hard. When you go to sleep at night, don't concentrate on that problem that you're trying to solve. Instead, just make sure it's there. And if you find yourself coming into consciousness in the middle of the night, don't try to help the elves. Instead, lay off. And in the morning, just try to retrieve the good work that they've done. I could go on and on about this, but the clock says no. And so let me simply note that there has been some serious recent research done on this, all under the heading of hypnagogic sleep. Very interesting. You'll find, for example, that most creativity happens shortly after you first fall asleep, rather than later on in REM sleep, and so on. I'll leave it at that in order to move to the next, we're getting near the end, word of advice, and that is juggle. Absolutely do multitask. Do try to address multiple things at once. Not because your work on one is likely to inform your work on the other, but the momentum on one is likely to inform the other. When I was working on my dissertation, I can remember deliberately how I would never do the dishes at night. I'd always wait till the morning so that I could do those dishes and feel so proud of myself that I'd accomplished something that day, that it would set me up for writing a whole paragraph. So we're getting near the end. I don't have enough time. I didn't have enough space. So let's deal with these two words of advice together. You may assume from the graphic that I'm proposing something that relates to an intoxicant. You couldn't be more wrong. I'm talking about getting high on, well, this will depend on you, on music. I drove down from north central Massachusetts this morning with Janis Joplin, and I expect to go home in a few moments with Sam Cooke. Yeah, he's out there in the car right now, I think, waiting for me. When I get home, I can assure you that my new puppy is not going to be of any help, but my kitten absolutely will give me just the sort of frame of mind that I would otherwise perhaps get from that music, or perhaps a beer. But the reason I selected this slide is for a reason that is much more substantive, actually. What you're looking at is some students who graduated a few years ago from a class that at this point was teaching how to use JavaScript to make use of parallel processing cloud-based servers. And they wanted to make a point about using functions. And so these three students took it upon themselves to drive an hour and a half north to this microbrewery that they knew I enjoyed, and make their point by way of a little video. I don't need to show you the video. You get the idea by just looking at the looks on their faces. I would argue that these students are getting high on something that I've come to know and appreciate around here, and that, frankly, is each other, the camaraderie, the kind of, I mean, they drove an hour and a half when they didn't have to make this point, the kind of commitment that students here will make to go have a beer. I mean, to satisfy their professor. It's the reason I love Yale. So as I said, you are not going to have any questions, but you did enjoy this talk. You didn't learn anything that you didn't already know. You are going to think about this tonight. And so I'd like to leave you with a final problem. It's one that I've actually posed to the students in my class that meets tomorrow. And it goes like this. You're looking at a landscape. It's a landscape of land and water. You can decide which is which because it's 50-50. There are just as many dark as light pixels as you see here. The question to you is this a landscape of islands or a landscape of pools? As you're thinking about this, I'd like to add a 13th word of advice that just occurred to me now, and it is conspire. Conspire, it occurs to me now, is a wonderful word, actually, from the Latin, to breathe with. Isn't that beautiful? Imagine that you're trying to solve the problem that I just assigned as a committee, I shouldn't say a committee, that's a dirty word, a group of 5 people. What kind of process would you go through? Well, my word of advice in terms of conspiring is recognize that you're going to go through a propose, dispose, propose, dispose, propose, dispose process. And my strong advice to you is recognize that individuals are always better at proposing, and committees are always better at disposing. We do still have a few more minutes. I know you have no questions, but I bet that you have been responding to my request to pick one of these that resonated with you. Anybody willing to offer? I didn't think so. Let's call it a day. Thank you very much, everyone.